So we're now going to 5.2 guided practice, which is going to start to teach us about congruent triangles. Okay, so this is a new concept, in part at least, to everyone, and the objective is determine ways to prove that triangles are congruent. So we're going to approach this slowly, and we're going to start by constructing triangles in different ways and looking to see if the resulting triangles are congruent. So in number one, we're going to construct a triangle with sides whose lengths are the same as A, B, and C. So we're going to construct two different triangles, putting the same side lengths in different orders and then comparing the two triangles. So let's go ahead and do this, and you're free to follow along with me on your own. Let's take a look at A. And on ray RS it says construct A. So construct this length. And then construct B on the left and C on the right. So let's start by constructing A. So I'm going to do this with a compass. I might do it with a protractor also at times, but let me start with a compass. To construct A, I have to get the length of A, adjust the width of my compass to be the length of A, and then come down here to RS and make a little arc. Okay, so now this arc, and it looks like my compass is a little loose, but let me try to do this by holding it a little bit. Okay, so this is approximately where I'll end up, is about over here. So this is length A, and maybe I can also do it with a protractor. Then construct B on the left side. So how do I construct B on the left side? Well, I'm going to be creating a triangle A, B, and C, and I don't exactly know what angles they're going to be. So I know the length, but not the angle. So I'm going to use my compass to draw a circle around the left side of length B. So I'm going to make a length B, adjust the width of my compass to be exactly equal to B, like so. And then B is on the left side, so I'm going to place the sharp end of my compass on R, and then I'm going to make an arc around R, the length B. So here I go. Okay. Now construct C on the right side. So I'm going to take my compass, readjust the width to the width of C. Make sure I have the right width here. Okay, that's just about the right width there. Okay, and now I'm going to go on the point that I created over here, put my sharp point on that point, and now intersect the other arc with the length of C. Whoa, bad compass. Okay, let me try that again. That's about the right length of C. I'll try it one more time, and that arc is the good arc. Okay, good. So I've got an intersection point over here, and now I'm going to use my straight edge to complete drawing the triangle. So I've got one side over here, and I've got one side over here. Oops, do that a little bit better. Okay, so there's my triangle, and now on the right side I've got to create the same lengths but in a different order. So first I have to, on the ray RS, construct B. Now I'm not constructing A this time, I'm going to construct B. So let me go back, take my compass, measure out, well, yeah, I'll do it with a compass. Measure out the length of B, like such, from here to here. Okay, so that's about the length of B. Go down here to R, and before the compass gives me any trouble, let me make an arc right over there. Okay, good. So I have length of B. So this is the length B. And then on the left side, construct A on the left side. So let me go ahead with the compass to get the width of A. Okay, and on the left side it's A, so I'm going to put my point on R over there. I'm going to make a very broad arc. I have a length of A. Okay, good. And now on the right side, which is at this point, I have to construct an arc with a radius of C. So let me go ahead and readjust my compass to C, like such. Okay, and on the right side, I'm going to make C. So now notice the two arcs are going to intersect at some point. Oh, I can't. Gosh, this is really a bad compass. It's so flimsy, but I'm going to keep on trying to make this work right. Okay. And then let me try once again on the right side here to make an arc with length C. Okay, I managed to do that over there. So that's where my two arcs intersect. I'm going to go ahead. I'm going to make a point over here. And I had a point over here. And I'm now going to join these points together. So let's join these 2 points. And let's join these 2 points. Okay, and these are my 2 triangles. Let me make sure I label my sides correctly. So on this first triangle, the left side was B, the right side was C. Okay, on the right triangle, the left side was A, and the right side was C. Okay, so here are my 2 triangles. Notice I constructed them in different ways, but that they have the same side lengths. In other words, in this position it look kind of different, but they have the exact same side lengths. And the next task is to trace the first angle on patty paper and compare to the second triangle. So let's go ahead. Let me trace this first triangle on patty paper. Doing the best I can. Okay, there we go. There's the triangle on patty paper. And compare to the second triangle. Well, what does that mean? Well, let me try to move this patty paper around a little bit so that maybe it is in the same position that the first triangle is in. Let me move it around a bit here and there. Okay, that looks a little bit better, right? Is that in the same position? Well, not quite, right? Let me see, is there a way to get it in the first position? I can line up this side. I can also line up this side. Well, what do I have to do to see if they can go right on top of each other? Oh, I know. I probably have to, maybe I have to flip the paper over, right? So let me flip the paper over, and let me see now if I can put one triangle on top of the other triangle. Let's take a look and see. Looks good. Looks good. Yep. I can. Okay, it is possible when you trace the first triangle, either through moving around the patty paper or flipping it over, it is possible to be able to superimpose it perfectly on the second triangle. When you can do a thing like that, when you can trace the first triangle on a piece of patty paper and then move it around or flip it over in such a way that you can fit it over the second triangle, we call that a congruence. Okay, so 2 triangles are congruent if you can place one directly on top of the other using a series of transformations. In this case, we had to include reflection because we flipped the paper over. So what can we conclude? We conclude that triangle, and I'm going to just call the triangle number 1 and triangle number 2. Okay, I'm going to conclude that triangle number 1 is congruent to triangle number 2. That is my conclusion. I would write this as triangle number 1 is congruent to triangle number 2. And that's because I can superimpose one image on top of the other perfectly. But this tells me something also. In addition to the fact that these two particular triangles are congruent, it tells me that whenever I have three sides or three corresponding sides that are congruent to each other, in this case I've got this side labeled A, and I happen to call this side A. Let me call these primes just so I can indicate that it's a different triangle. But here I've got the length of A is equal to the length of A prime, the length of B is equal to the length of B prime, and the length of C is equal to the length of C prime. What I'm saying is that each of the corresponding sides has equal measure. We call a situation like this side, side, side congruence, okay, of triangles. So when we have three sides, all of which are equal in any two triangles, that automatically implies that the triangles are congruent. So if we look down here at this puzzle down here, where we're given that side AB or line segment AB is congruent to RS, let's put a little hatch mark to indicate that over here, and that line segment BC is congruent to ST, so that means that BC is congruent to ST. Notice I'm putting 2 marks in each of these to show that these two sides are equal in length. And finally, that side AC is congruent to RT. I'll put 3 marks in here to show that these two sides are equal. Then we have a statement that we can make that triangle ABC is congruent to triangle RST. Notice ABC, RST. The order matters. We'll talk a little bit more about that later. But I can say that triangle ABC is congruent to triangle RST because of side, side, side. Okay, because of side, 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 because the three sides are congruent. So my reason here is side, 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 or I can say corresponding sides are congruent.